All right, welcome guys. In this video, we're moving it along to section 8.3. We're looking at the converse of the Pythagorean theorem. Now we know the Pythagorean theorem says if we have a right triangle, then we know a squared plus b squared equals c squared. So this, we're just flipping it around the other way. We are saying if we have a triangle where it's true that a squared plus b squared equals c squared, we know it is a right triangle. All right, so this is the converse of the Pythagorean theorem written out. You do not need to copy this down. In words, it says if the sum of the squares of two sides of a triangle equal the square of the third side, then it is a right triangle. So again, if a squared plus b squared equals c squared, then we know the triangle is in fact a right triangle. On the next slide, we are going to look at some common right triangle lengths. All right, they are known as Pythagorean triples. Okay, and when I say Pythagorean triples, that just means some common right triangle lengths. And again, we can see with the two shorter, if we square the two shorter sides, add them together, it'll equal the square of the longer side. So for this first one, 3, 4, 5, we can see that 3 squared plus 4 squared equals 5 squared. That's 9 plus 16, that equals 25. All right, so if we have a right triangle and we see it's got legs 3 and 4, we can immediately say, oh, boom, I know that hypotenuse is equal to 5 because 3, 4, 5 triangles are right triangles. Now we need to be careful. 5 has to be the hypotenuse. Sometimes people get tripped up. They'll see a 3 and a 5 and they say, oh, that must mean that 4 is the hypotenuse. No, if you have 3 and 5 as the legs, then the hypotenuse is going to be something different. It's if the 2, 3, 4 are your legs, then 5 is the hypotenuse. All right, another common one is 5, 12, and 13, and that's because 5 squared plus 12 squared equals 13 squared. Don't believe me? Plug these in a calculator. That's 25 plus 144. That equals 169, which is 13 squared. All right, so again, if we have a triangle, legs 5 and 12, the hypotenuse we can immediately say is 13. We can skip over doing the Pythagorean theorem. Okay, if you get 5 and 12, don't waste your time going 12 squared plus 5 squared. Boom, you just know it. That's 13. Bang, we're done. And the last one we have is 8, 15, 17. Okay, 8 squared plus 15 squared equals 17 squared. Again, you don't believe me? Fine. I mean, it's foolish of you not to believe me, but 8 squared plus 15 squared is 17 squared. 64 plus 225 is 289. All right, so let's say I have this triangle right here. I've got 8, I've got 17. I know that other leg is 15. Don't waste time doing the Pythagorean theorem. We already know that that is a perfect, that is a Pythagorean triple, and this leg is 15. All right, another important thing to note is that any multiple of these sides is also a Pythagorean triple. All right, it will also be a right triangle. So if I were to multiply these all by 2, and I get 6, 8, and 10, we can see those sides are in proportion to the 3, 4, 5. That's also going to be a right triangle. If we multiplied them all by 3, and we had 9, 12, 15, that's also a right triangle. 9 squared plus 12 squared equals 15 squared. Okay, so if you see those, remember, let's not waste time doing the Pythagorean theorem. If you got legs 6 and 8, boom, mark down that hypotenuse as being 10. All right, don't spend time doing the Pythagorean theorem. Now, what if c squared is not equal to a squared plus b squared? What if it's greater than it? What if it's less than? All right, so what we are going to examine on this next slide is what happens when c squared doesn't equal a squared plus b squared. So I've drawn 3 triangles here. This first one we can obviously tell is a right triangle based on that right angle at A. And we've got our hypotenuse. Our longest side is this side here, BC. Then for the next one, same thing. Our longest side is BC. We can kind of see that this BC looks like it's longer than that one. Okay, it appears to be a little bit longer, even though AB and AC are about the same length. Okay, the only difference being this angle is greater than 90. So that's obtuse. And for the last one, BC is still our longest leg, maybe. Here, let's try and make that look a little bit better. Let's say we go here, here. So BC is still our longest leg. However, it looks like it's shorter than in the red as well as in the black. And now we can see that angle A is actually acute. Okay, so our largest angle is acute. That's an acute triangle. So what we've come to find out is if A squared plus B squared equals C squared, we know it's a right triangle. Okay, if A squared plus B squared is less than C squared, then it's going to be an obtuse triangle. And if A squared plus B squared is greater than C squared, it is going to be an acute triangle. All right, please do note that C is always the longest side. Okay, C is the longest side. A and B doesn't really matter, but C is your longest side. And the last thing to remember, all the way back from chapter 6 actually, is that for 3 sides to make a triangle, so for 3 sides to make a triangle, we know that A plus B has to be greater than C. So this sum of 2 sides has to be greater than the third side. Then we go to the squares to figure out, is it right, is it obtuse, or is it acute? So let's do a few example problems here. Let's start with 9, 10, and 11. I'll do 9 squared plus 10 squared, and I want to know, is that equal to, greater than, or less than 11 squared? That's 81 plus 100, relationship to 121. I get 181, which is greater than 121, making this acute. If you can't remember if it's going to make it acute or obtuse, what I would try is just use the lengths of an equilateral triangle, right? 6, 6, 6. Try that out. Okay, 6 squared plus 6 squared is going to be greater than 6 squared. So obviously then you can see, oh, well, an equilateral triangle is an acute triangle. So this is going to be an acute triangle. For the next one, 3 squared plus 6 squared. Relationship to 8 squared. We get 9 plus 64, 36. I got ahead of myself. And what is that relationship to 64? Well, we get 45 is less than 64. 45 is less than 64, so this is going to be an obtuse triangle. And lastly, for 3, 4, and 8, don't get tripped up. 3 plus 4 is less than 8, meaning this is no triangle. We can't make a triangle out of that. All right, let's try just one more, actually. Let's go to D. And let's say we got 6, 8, 10. Immediately looking at that, I can identify that as a Pythagorean triple. That is a right triangle. Okay, again, we know 6 squared plus 8 squared is equal to 10 squared. All right, best of luck as you get going on the homework.